It really did look pretty good. Why are we still on factoring?
Because we suck.
I'm not gonna word it that way. Because let's word it a little nicer than that. Because if I recall, we were struggle busing before spring break because our attention span was a little gone, and now here we are after spring break, and suddenly our attention span is still a little gone. Like, oh my, Miss Compton is moving on from factoring very shortly. Know that the end of the road for factoring is happening one day next week. I need to add to that list for today. Anything with an asterisk is going to end up being part of a 60% category grade. You are going to have homework tonight. Welcome to the weekend. We're off school on Wednesday. Learn the deal. We are going to finish 19 through 24 on the other little thing. We're going to fill in this spot on the flip book. And then we're supposed to do a checkpoint too. We had a lot we were supposed to do, so that darn fire drill is just not my friend. Okay, leading coefficient of not 1. The issue is that we're trying to get ready to do all these problems at once. Because right now, Natalia's great at greatest common factors. She's good at when leading coefficient is 1. Clearly, we all are. We flew through that activity. But of not 1. When the leading coefficient is not 1, we use the ninja star. I need you to, every problem you see, try GCF first. Try GCF first. You might not have to use the ninja star. If there is a GCF, you need to check. Okay, we had a problem the other day that I thought we would try on the GCF flap that we would come back to. It is the 6r squared plus 29r minus 42. So our first problem today is 6r squared plus 29r minus 42. That's going to be our first problem today. Now what's going to happen is Natalia's going to follow this well, and then I'm going to throw out a GCF and LC equal to 1 checkpoint, and she's going to forget how to do those. So I need somehow in her brain for her to be able to do all 3 different kinds. Because she doesn't know, they're not going to spell out to you, hey, this is this on a test. They're going to be just factor this, and you have to know the different methods we can use. Okay, so far we filled in GCF and LC equal to 1. I'm on a flap that says LC not equal to 1. Okay, so if the leading coefficient is not 1, we have to think about a ninja star. The A goes in these slots, the B goes down here, and then in the top I do A times C, which is going to be a really big number because 6 times negative 42 is a really large number. What is 6 times negative 42?
Negative 252.
Negative 252. So this seems like a really hard one. Do you know anything that multiplies to 252?
No.
I assume 4 goes into it, so let's just start with the beginning. So I'd make my little chart. How many times?
63.
4 and 63, they're not going to be only 29 apart. We're going to have to come up with a much bigger one. Does 16 go into it? No. Huh?
18 and 14.
18 and 14. Yeah, but those are 32 when put together, not 29. We need 29. That was really good, though. So one, does maybe 20-something? 22? 21?
21 goes in 12.
21 and 12. Well, that would get us to 33. Still not quite there. We are at 32. Now we're at 33. It seems like we're going the wrong way, right? So maybe we need to go smaller. You said no to 16. What about 4? You already got 14 up there. Already got 12 up there. I don't know. Pick another. 6 and what?
42.
Is it 42? Okay, well, they don't have a difference of 29, so that's not right. Anything else? 7 and 36. Does 36 and 7 have a difference of 29? Yeah. So she's finally stumbled onto it. So it's going to be a negative 7 and a positive 36, she says, because 36 minus 7 is positive 29. So in my Ninja Star, I fill in a negative 7 and a 36. Now, I picked this really hard example on purpose. Normally, ours are not this difficult, are they? No. I wanted to prove that we could persevere through a hard one. My golly, we can do anything. Okay, what are my two factors? One of them pops out easily. Which one pops out easily? 6 over 36 reduces to 1 over 6. Yes, so what should I write for that factor then?
R plus 6.
R plus 6. Yes. Okay, what about the other factor? It's even easier. It can't reduce. So what's the answer? 6R minus 7. Okay, again, so let's say we filled in. Does everyone understand how I filled in my star? And now we're trying to decide, can we reduce our stars? And we could on this side. We got 1, 6, so we have R plus 6. And on this side we have 6R minus 7. How can we check ourselves? We could foil. We could foil to check ourselves. Are there any questions about that Ninja Star one? Everyone in the room, besides Natalia, who just voiced her opinion, if everyone in the room seems pretty good at the Ninja Star one, let's look at, let's try another. And I'm going to make it another giant one just to prove the fact that we can do a giant one. 12x squared minus 29x plus 15. And it's going to be another huge one. We'll probably only get to these two examples to fit in our flap. It is another huge one because when I'm working with my star, if I put A here, I put B here, I need to do A times C, which would be 12 times 15. I don't know what that is. 180. So I need something that, again, adds to negative 29 and needs to multiply to 180. So we got to think of things that multiply to 180. So 180, 9 and 20. Now that one was a lot easier. That one just popped on out of her brain. I was thinking 18 and 10, and I was on a different thought. A 6 and 30. I got 36, but she's right. 9 and 20 multiplies to 180, and 9 and 20 give you a negative 29 if they are both negative. So my factors are negative 9 and negative 20. Are there any questions about that? I need to reduce both sides of the Ninja Star. 12 over negative 20, I need to know what it reduces to. Yes, 3 over negative 5. So how would I write that factor?
3x plus minus 5.
Okay. And then what does the other fraction reduce to?
3x. 4 plus
4 or negative 3, so you would get 4x minus 3. Agreed. And then again, I know I'm right just from doing the first step of FOIL. If I do the first in my head, 3x times 4x, that is 12x squared. So I'm betting we're right. Okay, and then I swear I'll do a much easier one. We'll keep it simple for the last one because we're really out of room and I think you've got it down. 6x squared plus x minus 2. Much smaller. I put A in its slot. I put B where it goes. A times C would be negative 12. I need something that multiplies to negative 12 and adds to 1. Yes. Okay, so I know you had a list of 12 in your head, of 1 and 12, 2 and 6, 3 and 4. 3 and 4 would be the best because they have a difference of 1. 4 minus 3 is 1. So it needs to be a negative 3 and a positive 4. Okay, both these fractions reduce. What does 6 over 4 reduce to? 3 over 2. So what do I write my factor as?
3x plus 2.
Okay, and then 6 over negative 3, that reduces as well. To what?
3 over negative 2.
Is it 3 over negative 2?
3 over 2.
6 over negative 3.
2
Yeah.
over negative 1.
2 over negative 1. So my other factor is 2x minus 1. Now let's say you had gone down that wrong bunny trail and you had reduced your fraction wrong. You should have realized it right then, because my first step, I at least do the first in my head. 3x times 3x would have given me 9x squared. And so I would have known I wasn't right. 3x times 2x gives us a 6x squared. So I have a feeling I'm right now. Are there any questions about this? Okay, then I'm going to assume you're good to go on that, and I'm going to go ahead and hand you your work for that and write it on the board.